We've just seen how you can approximate a line of best fit by eye, what basically is just an approximation about how you interpret the data based on what you're seeing. But now we're going to make this a little bit more mathematical, a bit more scientific, a bit more calculated rather than just approximated. And luckily, even though there's a massive, massive formula, or a series of formulas, to be honest, that lead you to finding the optimal or very best line of best fit, there's a lot of technology here to help you not have to use those formulas. So let's see where we're going with this today. The basic principle is this. When you're trying to find a line of best fit, we're performing an operation called linear regression. And what that means is you're working backwards to force fit a line on top of a series of data. Now, what makes the line of best fit the best one possible? You're trying to get these gaps between any proposed line or hypothetical line that might join your Cartesian plane to sort of straddle or weave throughout the data field. You're trying to make those gaps, generally speaking, as small as possible. So some of the points will reside above and some of the points will reside below. Now, how do you do that? Even if you don't have the line itself, how do you measure? Well, that's what those really fancy formulas are about. In our course, we're worried about, how to make this work for us rather than just how it works in general. So we don't have to prove this. We need to know how to use this. The problem is with these so-called residuals is that some of them reside above the line and some of them reside below. And if you just start adding them all up, as you well know, positives and negatives tend to cancel one another out, at least in some regard. So what some people have very cleverly done is they've thought about this instead of just square every residual, and that way they all become positive. And it's something that can be compared to one another. So you would take all of those squares and add them up because squares all have positive area. And this method is known as the method of least squares. And your calculator will do this for you. In fact, it'll even show you, as you'll see in an upcoming lesson. So enough talk about that. This is all done on your calculator. And so it's very precise. It's not a guess. It's not an estimate by eye like we've done before. There is one line of best fit that's considered best of all, most reliable, most worthy, and we just got to know how to harness the technology in order to provide it to us. So we're just going to do one problem today. I want you to get working on this yourself. Annual income and average weekly grocery bill for a selection of families is shown. Okay, so I'm guessing that families that are more affluent can and will probably spend more on their groceries. I'm not sure about that, but that's where I think this is probably going. It says we're going to construct a scatter diagram. Okay, we can do that. Use technology to find the equation of the regression line. There's the big news. There's the big development today, and I'll show you how to do that. We're going to interpret what the regression line actually means, and then we're going to use it to do some work inside the data field, meaning if a family earns this much money, how much are they likely to spend on groceries? Or if we know how much they spend on groceries, can we assume how much they earned in income by taking advantage of that line? And obviously these points here that we're going to be interpreting about don't fit perfectly into the data field, or we could just read them off. So the line of best fit is going to become a tool for us to better understand the data. And here we go. So like a lot of times you've already seen, I've put the data in and not bothered showing you where it comes, how I put it in. We're familiar with spreadsheets now. And I just want to make sure that the final one, the eighth one, is the final entry, 5150. It is. And so we're good to go. Here's how you make your scatter plot. Oh, by the way, first make sure your axes are big enough to take the data in. So you're going to go here, going to go scatter plot, number 6. I'm going to type in what I typed in on my spreadsheet. You can tell. Is it boldface? And there it is. Now make some tiny adjustments to the window so it's nice and visible. And there you go. Now that the data's in, the columns have been nominated on the spreadsheet, we can go ahead and do the big reveal. And here it is. Stop if you need to. Stack calculation. I think I'm going to actually stop it right here too. Oh, I'm first doing the two variable analysis. We'll resume my video here inside. Just want to make sure that the R value is high enough to make it an appropriate tool to use. And sure enough, 0.89, it clears that threshold of being worthy of a linear regression or straight line analysis. So we're going to go ahead and commit ourselves to finding that straight line. There's the mean, the x, and the mean of the y's. That's going to be useful. You'll see later that our line of best fit will go through that point. It has to go through that point. And so now we're going to, on a calculator page, hit pause if you need to, we're going to go into the menu, stats submenu, stat calculations, and we're going to look for an option called linear regression. And here we go. There's our R value, 0.89, and our mean and means are there. We're all set to go. Don't worry about all that other stuff. Statistics, stat calculations, and there it is, number 3, linear regression. And notice that the format of the line is y equals mx plus b. There's a lot of cool stuff going on here. And I'm going to hit pause again, I think, because I want you to notice something. I put that the x list is found in the income of the spreadsheet. The y list is the grocery bills that they paid, also on the spreadsheet. I've done the scatter plot. We've seen the R value is 0.89, so this is an appropriate thing to do. The calculator is about to tell me in the format y equals mx plus b, which is the equation of a line, what the line of best fit is by doing that least squares analysis. Now you're not, forced to see all of the workings about it because it's massive, it's long, and it takes a lot of time with pencil and paper to work it out. But here's the point that's highlighted in the middle of your screen. It's a save regression equation to F1. What does that mean? It means when you go back to your data field in the scatter plot, if you were to ask it to then graph F1, it automatically will remember this straight line equation and put it in there. You don't have to even write it down. Let's continue now. And there it is. Y equals mx plus b. M is 4.18-ish. B is negative 56.69. And there it is. Now, if I go here, I can hit menu, graph, hit pause. Now, I want you to notice when I hit the menu button, went to add a function, the first option it gave me was F2. Why F2? What happened to F1? F1's already been pre-installed with the regression equation that you computed on the previous screen. So if I go ahead now and indicate that I want to go up to the previous one, I'll let the video just play out now. You can see I go up to F1 and there it is pre-installed. So if I just hit enter, it'll graph it for me. And you can see that it sits directly on top of that data field. And it is the best line of best fit. It's the optimal line of best fit. If I trace the graph, I can go ahead and find different interesting places. For example, if I type in the mean of x, notice that it sends back the mean of y, because that point is automatically, that's the mean of the two data sets. Go back up here, you can see that the mean value of x was, where is it? 47.7375. Mean is 141.25. If we go back now, you can see that that point's on the line as well. Okay, so let's go how we're going to use this information. I've readjusted my screen so I can see everything. I've got room for interpolation, and if extrapolation is attempted, I've got space for it up there in the upper right. I'm not sure I'm going to want it or depend upon it. So here's the first one. We're going to estimate the weekly grocery bill for a family that earns £95,000. Income is down below, measured in thousands of pounds. So I'm going to go trace all of it. I'm going to change that to 95, which I've just done. And you can see that this is an extrapolation. And if I want to type in the other one is 100, and I look for where these two cross each other, and this is for answer for E part, find at the intersection, and there it is there, which is you to guess the family that spends $100 on 100 pounds of groceries would be earning about 37,500 pounds of income. Okay, so that's how this works. Interpolation, extrapolation, line of best fit. It is the optimal line of best fit. It's based on the theory of those little tiny squares, which you probably will never have to do on your own. I say probably because some students will choose to do a stats-based internal assessment, in which case you may have to do this kind of stuff, but that's not a given. Comment for part F, it says the estimates for D, they're likely to be reliable. I'd say the answer for D part is less reliable because it's based on an extrapolation. Just because they earn, it's a much more affluent family doesn't mean they're just going to spend it all on groceries. They may have other things that they'd like to have. But E is probably more reliable because it's within the data field and therefore an interpolation. Not a guarantee, it's just probably more reliable. We're up to F. We're getting already near the end of the chapter, so let's not let our guard down. We've got a couple of questions here. We're going to be finding the line of best fit using our GDC. We're going to be making some graphs and then doing some interpretations of them. So there's only a couple questions here to do, but as always, they're important to do. Questions 1, 3, and 4. Again, like I say, you can see we're getting quite near to the end now. All right, good luck.